Okay, we're back at it again, and we're these ideas and terms are going to come at you one after the other. You're going to see them again within math, and you're going to see them again for sure within engineering and applying it to civil engineering for the rest of your career. And so if we go back to the first initial video, if we call these 1, 2, which they don't quite have a number yet, we saw that the slope-intercept form of a line is something that's usually written in the form y equals mx plus b, with b being the place that the line crosses the y-axis, the value of y when x is 0, and m being the slope of the line, with a 45-degree line having a slope of 1. Now, for those of you who are really versed in math, you're going to realize that there may be other places where something has a slope of 1 as well, but essentially it's in the first quadrant. In other words, between 0 and 90 degrees, where the slope of a line that is at 45 degrees has a value, or the slope is a value of 1. So what you'll soon be able to kind of visualize and hopefully think, even without using computer tools or calculator tools, is to think, okay, is something a line? And we'll see why later on. You can decide it's a line or a parabola or a circle. And then what is its slope? How does it trend to go up? How does it tend to go up? Is it increasing or decreasing? And then how shifted is it from the origin or the 0, 0 point? So that's something that you're going to develop, and we'll talk, and you will talk lots, and you already have at some point, going all the way back at some point within your mathematical career, to when we were putting our friends' pigtails in the inkwells from my age group. All right, so let's go to the next step. Let's assume a line has a slope m. Let's give it an easy one. Something has a slope of 1. That means it goes up 1 for every 1 over. It means it's a 45-degree line. Or for those of you who are starting to think about the circle, as you should, it's 45 degrees or pi over 4 radians. 45 degrees. All right. So if the slope of that line is 1, what is the slope of the line that is its perpendicular? And you're going to see me doing a lot of this. Get used to it. If this is the line, and that has a slope of 1, what is the slope of this line? What is the slope of the perpendicular, any perpendicular, to a line with a slope of 1? The answer you will soon discover is -1. Does that mean that if the slope is 2, that the slope of this is -2? No. It means that the slope of the perpendicular line to any given line is the negative reciprocal of the slope of the line. So I'm going to give you 3 slopes here visually with my arm, approximate, and then what the slope of the perpendicular line is. We'll start with this one. That has a slope of 1. Therefore, the fraction of that is 1 over 1. The reciprocal is 1 over 1, and it's a negative 1 over 1. If something is a little bit, or is less slopey, it might have a slope of a half. So therefore, to take the reciprocal, you take the reciprocal of 1 over 2, or 2, and you make it negative. It's a -2. Let's say, on the other hand, the slope of the line was greater than 1, or greater than 45 degrees. It was something like 2. Therefore, the slope of this would be -1/2. And you'll see as we start looking at some software that some of you may or may have not had in school, as I move this way, one slope dictates the other. A change in this slope causes a change in this slope. But we know that the perpendicular line in a 2D Cartesian coordinate system is always equal to the negative reciprocal of the slope of the line. that becomes extremely key in many, many different things. And as we look at software solving all our problems, we can also look at software causing the one particular problem which causes some sort of cataclysmic failure. So we do not want to lose sight of some of the basics. And so the first two basics we have is that lines can best be processed in your brain, not by a computer necessarily, but best processed in your brain by writing them in the form, if you assume y is the dependent variable and x is the independent variable, writing them in the form y equals mx plus b, realizing that m tells you the slope and b tells you the slope-intercept, and then realizing that you take the negative reciprocal of the slope to get the slope of the intersecting set of lines. In other words, we will talk about, and I think that now is a good spot as we're trying to fill basically 10 minutes at a time here, lines in a plane. Not snakes in a plane, lines in a plane. And you will learn within math, or you learn within math, that if you have two lines in a plane, those two lines can fall into these three groups. The first one is they could be the same line. In other words, things might be disguised so you don't quite realize that they're the same line. An example would be if you have fractions involved or something like that. So they could be the same line. In other words, it's one line on top of the other. That's your first option. The second option is they could be parallel. They will be parallel if their slopes are the same. If they're exactly the same, they will be parallel, and they will never intersect. They will never collide in a 2D coordinate system. The third option, which is, I'm not going to say it's more common than the others, but it's what we spend a lot of time with in mathematics, deciding and calculating in algebra, or geometry, is the two lines intercept. So those are your three options. Two lines in a plane can either be parallel, they can be the same line, they can be parallel, or they can intersect at some point. Now that point might be 1,000 miles away in a 2D plane, but they will intersect. If they're not parallel and they're not the same line, then they will intersect. Those of you in the technical program that are using AutoCAD for drafting, you'll see that becomes pretty evident, and you'll be, I'll be infusing some of these videos with some snippets from AutoCAD or SketchUp or SolidWorks or some other program to kind of show you that these are not pure algebra or pure geometry in the kind of compass, not compass, but compass mode. We will be looking at the fact that mathematically lines in a plane can either be the same line, they can be parallel, or they will intersect at some point. All right, so we got about a minute left here, and it's not like I'm filling the time, but we're trying to kind of see how long these things load up out to YouTube as I'm going through these initial parts. So let's do the big review, and some of you, I'm going to have you actually use something called annotation and stick it out or type in what you know or don't know or whatever. Okay, and let's start. If you've got a Cartesian coordinate systems, x's and y's, the y is called the dependent axis, and the x is called the independent axis. If I've misspoke prior to then, in other words, x drives the value of y. Y is caused by x. If you write a line, any line written in that coordinate system can be written in the form, the slope-intercept form, y equals mx plus b, with b being where that line crosses the x-axis, the slope-intercept, and m being how many up the line goes for every over, something called the slope. Finally, to review, the negative reciprocal of the slope is the slope of the perpendicular line. Thanks for listening. Bye.